అందరు కొత్త కూర్చోండి ముందు ఎవరెవరో వస్తారు ఎంతమంది మాట్లాడుతున్నారు టైం అయితే లేదు
Welcome to the dynamic learning hub of ExcelR at Andheri East. A prime spot conveniently located at just a 5-minute walk from LIC Andheri Metro. In our journey of over a decade, we have proudly trained over 2 lakh students. We have also been recognized by Deloitte, Silicon India, and other accreditation bodies. Experience learning like never before in our spacious and comfortable classrooms. With high-definition projectors and state-of-the-art acoustics in place, we ensure effective learning even to the farthest point in the room. A hybrid mode is a game changer as you can enjoy the benefits of a live classroom from the comfort of your home. Even if you happen to miss any classroom session, you can still attend the same session with the same trainer at the same time at your convenience, maintaining consistency in your learning progress. Wanna get started? Join us for a demo or career chat over a cup of coffee at our Andheri branch. ExcelR. We don't just train, we build careers.
Yes, so the collaboration with ExcelR was an excellent one. We conducted a Power BI workshop with Advanced Excel over a span of 3 days. The workshop was almost 12 hours long in total. Mr. Karthik, who was an amazing trainer, helped the students understand the concepts deeply. I am sure that the students will be able to apply these concepts in their careers as well as their daily lives.
The trainer, Mr. Karthik, was an excellent person where he explained in very detailed manner on how to give great insights using very complex data sets.
So it was a machine learning workshop. We learned a lot from the course and it was a great experience attending the workshop.
The trainer was very helpful. He had a hands-on approach with his teaching and it was fabulous.
This was a great experience for me. So I would absolutely love it if ExcelR and its team would come again to our campus and conduct more events like this.
It was a great course and it started from basics and took me to a great extent.
The experience of the workshop was really nice. The feedback from all the students was positive. They understood the concept. The workshop was also practical based with some questions. The experience with ExcelR was very smooth. They helped us in conducting the workshop smoothly right from the booking of the vendor and deciding the course till the distribution of certificates. In overall, this workshop was a success during our technical fest Atmos, and I thank ExcelR for being a part of it.
very much interested in learning digital marketing course for a very long period of time, but I don't get a proper platform. So later from our college, I get to know about ExcelR and I enrolled in ExcelR course. It was really good experience. Our course has been taken by Mayur sir, and he was very good teacher. He not only focusing on theory part, he is doing how real digital marketing works, and it was in total very good experience. I get so much of knowledge. Here they're not only focusing on study, they're also conducting different exams to test our knowledge. And as we are giving the exam, so to appreciate our work, they give certificates for the toppers, and along with the certificate they give hampers. Thank you, ExcelR.
Recently I was searching for digital
Good evening all. I hope you all doing well. So students, still the trainer to join the session. He is joining in 2 minutes. Kindly wait. Okay, we'll wait for 2 minutes. Then trainer will start the session. Kindly wait for 2 minutes.
and I came across ExcelR and I attended a digital marketing course which was for 15 days. My mentor Mayur helped me for attending these classes. So he is a very informative and helpful guy. In the course end, there is a exam which I topped. So I came to the ExcelR office in Bengaluru. This digital marketing course has helped my career and my skills to develop, and the certificate has helped my company to join. Thank you, ExcelR.
I came to know about this course from my college. Actually, for learning platform, this is very nice, and I learned from here ChatGPT and AI.
Hello.
Yes, sir. Good evening, sir. You can start the sessions.
Good evening, Susmita. Guys, good evening, guys. Can you give the reply? Susmita, change it to the only personal chat. Don't make to the other people.
Yeah, sure.
Akshara, all the people. Fine. Yeah. Can you tell the tree, guys, what we completed yesterday? Tree, na? Yesterday we completed. Can you please reply? Yesterday what we completed? Tree, na? We completed the tree. Fine. Can you explain? You people should explain, is it a linear data structure or a random data structure? Tarun, you are saying the Tarun, what happened? Tree, guys, binary search tree. Binary search tree, is it a linear data structure or random data structure? Random data structure. It's a which one? Random data structure. Tree internally using. Tree internally using. It is using what internally? Double linked list or single linked list? Double linked list. Internally, it is using the double linked list. And one more point. And one tree. Coming to the tree. Tree left side insert root node. Root node left side. Root node left side insert what? Insert lesser values. reply, insert what? Lesser values. And another thing. One more thing, root node right side. Coming to the root node right side, insert the bigger values or highest values. Yes or not? And coming to the displaying also. How many approaches we have in the displaying? How many approaches we have? We have the three types of approaches. First one in order. First one is the in order. Second one, first one is the in order. Second one, pre-order. Third one, post order. First one in order. Second one, first one in order. Second one boys. Second one is the pre-order. Third one, post order. We have the third one. The third one is the post order. In order, pre-order, and the post order. Yes or not? Fine. Not only that one. Coming to the deletion also. Can you tell the approaches? Can you tell the approaches? What's the first approach? What's the first approach? Can you tell the first approach? First approach is the leaf node. Can you tell what is the leaf node? Can you tell what is the leaf node? The node without any child. The node without any child called as the leaf node. Next one. What is the second approach? What is the second approach? Node with only one child. Node with only one child. Next one. Can you tell the third approach? Can you tell the third approach? The third approach is the node with two childs. Node with two childs. Guys, if you want to delete node with two childs, can you tell the solution? Can you tell the solution? Can you tell the solution? In the left tree, identify the, guys, what happens to Gyasha? In the left tree, identify the highest element and replace with the root node. And replace with what? Root node. And in the right tree, identify the min element and replace with the root node. And replace with what? And replace with the root node. Am I right or not? Yes. So this is the information we done. Fine. Yeah, guys, can I show some code on the deletion also? Some snippet on the deletion also? Can I show some snippet, some code on the deletion also? Yesterday, someone asked me show the deleted code also. Yesterday, what we done? Can you tell yesterday, Srishti, yesterday what we done? Yesterday, we completed about only insertion and answer. Insertion and what? Insertion and next one. We completed the searching also. Traversal and searching also. We completed the searching also. But let me show some predefined code. Before the session itself. I drafted some code. Then I will share that code to you. Guys, say this one. Here. What is the method? Everyone need to get a reply. Understand the only logic. Aman, understand the only logic. What is the method here? Can I tell what is the method here? Delete method. We have one method. That method we can call delete method. And here we are passing what? Here we are passing what? Data. We are passing what? Simply we are passing the data. Guys, this is a delete method. Calling which method? This is a delete method. Calling which method? Delete record method. Fine. For the delete record method, is it a root node? Is it a root node? Yes, this is the root. Guys, everyone, not only Aman. Only Aman Rahman is going to reply. At least by seeing that snippet, you people need to understand. Then only you are getting the benefit of it. Otherwise, you can't. By seeing that code, By seeing that code, you people are able to understand that code. Reply guys. Here, what is the method? Can you tell the method here? What is the method? Delete method. We have one method. That method we can call delete method. Fine. This delete method internally calling which method? This delete method internally calling which method? Delete record method. Internally calling one method, then that method we can call delete record method. Here we are passing what? We are passing what? Two things. One is the root node, another thing is the data. Fine. Now go to the delete record. Here this is the root node and this is the data. Fine. Now see this one. Shahil, see this one. If no root node, because no root node in the sense of no element. No element. Say this one. If root equal to null, return what? Root. So the meaning is what's the meaning here? If the tree is empty, I think nothing is there. Come on, nothing is there. If a tree is empty, return that tree. Fine. Next one. See this one. Data less than root dot data. Data less than root dot data. Answer. You people need to answer. Data less than root data. Search in where? Search in where? We need to search in left tree. Shahil, are you okay? Shahil, say this one. Data, whatever the data is there. If data less than root data, search in where? Left tree. We need to search in left tree. Then you need to go for the recursive call. This is a recursive method or not? This is a recursive method. Fine. If data greater than root data, fine. Search in which tree? Answer. Search in which tree? Search in right side tree. Guys, are you okay? Or can I explain the rough idea again? Can I explain the snippet again? Are you okay? Or can I explain the snippet again? Anyone? Lakshmi? Anyone? Are you okay with the logic? Next one. See this one. Node with only one child. Node with only one child or no child. Node with only one child or no child. Can you explain? If no left. Saida, where you are bouncing? Saida, you joined late na? Nehaban, you joined the late na? Huh? Say this one. If no left node, you need to search with what? Right. If no right node, you need to return what? Left node. Left node. Guys, I'm repeating again here. You people need to understand the flow. Yeah, you people need to understand. Say this one. Neha Banu, check this one. This is which method? Neha. This is which method? Delete method. I'm repeating again, guys. So they're asking again and again. Fine. This is the delete method. Lakshmi, for the delete method, what we passed? Lakshmi, for the delete method, what we passed the data. Here we passed the data. Yes or not? Fine. This delete method, calling which method? This delete method, calling which method? Delete record method. It is calling one more method. Then that method we can call delete record method. Fine. Is it a root node? Yes. Is it the data you wanted to delete? This is the root node and this is the data I wanted to delete. And I'm repeating again. Fine. Next one. How to check tree is empty or not? I wanted to check tree is empty or not. How we can check? Root equal to null. Root equal to null. We can't delete it. We are unable to delete it. Then we need to return the null only. Fine. Now see this one. Neha, try to understand Tukar Lakshmi, Thakur Lakshmi, see this one. If a data less than root data, if a data less than root data, searching where? Searching. If a data less than root data, searching left tree. Searching where? Searching left tree. And another thing, if a data greater than root data, do the delete operation in right tree. Do the delete operation where? Right tree. Got it or not? And another thing. One more thing is the node with only one child or no child. Node with only one child or no child. Node with only one child or no child. How we can handle? Guys, say this one. If left equal to null, you need to delete the right node or not? Answer. Right node or not? Right node. Next one. If right is the null, guys, understand the snippet, then your talent will be here. Assume here. Guys, so then you need to use your talent here to understand this one. Now, if right is the null, you need to delete left node or not? You need to delete the left node, Chatan. You need to delete the left node. Fine. See the another thing. One more thing is the, for example, if a node contain two childs, if a node contain how many values? If a node contain how many values? If a node contain two childs, yes or not? So find out the min value in, where? Find out the min value in right side or not? Right side. See this one. I want you to find min value in right side. Finally, that data will be stored here. Remember that one. Guys, see this one. Fine, assume this one. This is the min value. So I'm placing the, guys, whatever the logic we have, this logic is nothing but find the min value. And finally, that min value will be stored here. Whatever the min value will be there, that min value will be stored here. And coming to here, this code is used to delete it. Whatever the code we have, this code is used to delete it. Okay, but I think you may ask one question, sir, what about the left one? Only one thing is enough now. Only one thing is enough. Otherwise, if you need another thing also, create one more method. Which method? Max value root dot left, and create the max value. And here are the max value. And here itself, you need to press the root dot left. Here max value. Then same logic, same logic. But I'm implementing with what? Only min value. Min value in the sense right side or not? Min value in the sense right side. Why, sir? Are you people okay? Otherwise, if you ask me, sir, please explain again. I'm ready to explain. At least I'm expecting you people got the minimum knowledge about this code, minimum knowledge. Then anyhow, I will share this code, then you need to run it. Out of these people, guys, if anyone asking, cause sir, please revise it again here. I will provide the rough idea again. From min value, Harsha, say this one. Min value from where? Harsha, min value from where? Right side or not? Yes, sir. Min value from right side. Whatever the min value we have here, that min value we need to place on the right side here. Yes or not? Fine. So here, this is what? Min value. This is what? Say this one. This is what? Root dot data in the sense. This is the root data. And you need to traverse up to the downside or not? From beginning to top now. Beginning to top up. And here, this logic, Harsha, see this one. This logic is used to find min value. See this one. Initially, what is the min value? Node value. Later, that min value replaced with what? Min value, like root dot data here. Finally, we are returning the min value. Harsh, anyhow, I will share this logic. Then take the pen and paper, then you need to debug it, then you can get it. Okay, now. Fine. Guys, anyone? Anyone, guys? Can you tell the rough idea again here? Guys, this is which method? Third time I'm repeating. This is which method? Delete. This method internally calling. This method internally calling. Anyone? This method internally calling delete record. Guys, series one. What is this case? Guys, what is this case? Finding the, if the tree is empty, nothing. Guys, can you tell this one? If data less than root data, searching left, else deleting right. Guys, what is this one? Node with only one child or node child? Guys, what is this one? Node with two childs. Coming to here, this one we can call the node with the two childs. Yeah, guys, can I share this logic to you? Guys, can I share this logic to you? Can I share it? Yes. Let me share this logic to you. I'm sharing this logic in the pin here. Harsha, wait. Harsha, don't chat anything to me. Yes. Guys, I'm requesting all the people, please download that file. Please download that file and you people need to execute that code. Yes. Guys, I'm requesting all the people, please download that file. Please. So Smita, if possible, can you upload this code to the drive itself? Upload this code to the drive.
Yeah, sure, sir. I'm uploading it.
Karan, please tell me. Karan. Like here now in the step, you are asking this one, Tarun? Tarun, you are asking this one? This one? Yes, now say this one. Now I think This line number 72 is nothing but the deleting the root node and updating with the list value. That's the meaning. Shahil, we can use the anything, Shahil, not more than that one. Shahil, we can use anything. Replacement, that is a replacement code. Make it fast, guys. Whoever watching it here, please execute it and see the result. Are you able to get getting the result or not? Let me know, are you people able to see the result? Make it fast. Yes, Aswini. Yes. Nothing. This is the root node available globally. Satyanarayana, the root node available globally. See this when you were asking like, sir, we're passing the only one argument, but how we are getting the two arguments? There is a question. There's a question or not. That root available by default. That's a root node. That is inner class. Fine. Now, guys, can I continue? Can I continue? Reply. Can I continue? Yes. Guys, take the notes also along with me. Graphs. Take the notes along with me. Graphs. If you are okay, then take the notes or leave it. Fine. Now, guys, first point. Are graphs linear or random? Are graphs linear or random? Reply. Random. Fine. Now see this one. What are the graphs? Now check this one. Guys, if you check, right, observe this one. Guys, can you tell tree? Can you tell binary search tree? The node contain at most two nodes. No? The node contains at most two nodes. That's it. Only two is the last. Maybe 0 node or maybe 1 node or 2 nodes. Max is the node will allow how many connections? Only 2 nodes. For example, this is the root node. Assume this one. This is the root node. This root node at most contain 2 child nodes. 2 child nodes. Am I right or not? 2 child nodes. Then this concept we can call, whatever the concept we have, then this concept we can call binary search tree. Yes or not? But guys, what is a graph? The node may contain, coming to the node may contain more than 2 connections. The node may contain more than two connections, more than two child connections. Now observe this one. Observe this one. For example, this is one node, and this is the another node, and this is the another node, and this is the another node, and here we have the one more 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 node. Say this one. This node can connect to this node, and this node can connect to this node, and this node can connect to this node, and this node can connect to this node. And coming to here also, this node also can connect to this node. Not only that one, this node can connect to this node also. This node also, and this node can connect to this node also. And coming to here, this node can connect to this node, and this node can connect to this one also. Yes, multiple connections are not. Node may connect to number of nodes, multiple nodes. Then this concept we can call graph. Whatever the concept we have, then this concept what we call graph. So I'm requesting all the people, what is graph? Reply, what is graph? No one giving the reply now. What is graph? Node have multiple connections. Single node may connect to multiple nodes. Sometimes a node can connect to itself only. One node can connect to itself only. That is also possible here. Then that concept we can call graphs. Was it possible? Take the theoretical point. Take the theoretical point. I will take one point. Graph called as random data structure. Please note on the point of whoever taking the notes. Graph called as random data structure. Point number 2. In graph, one node may have multiple nodes connection. In a graph, one node may have multiple node connections. Multiple node connections. In graph, one node may have multiple node connections. And the third point. In graph, one node can connect to same node, can connect to itself. In graph, one node can connect to itself. Can connect to itself. Fine. Yeah. So let me draw the clear-cut diagram, then you can get the clarity here. For example, here I have the node 1, here I have the node 2. Node 2. Here I have the node 3, here I have the node 3, here I have the node 4, and here I have the node 5. So how many nodes we have? How many nodes we have? 5 nodes, na? 5 nodes. Now say this one here. And here, this is one connection. This is one connection. And this is the another connection. And this is the one more connection. So I say here also, this is one connection. This is one connection. This is the another connection. And this is also one more connection. And here also, this is also one more connection. Whatever we have, this one we can call one more connection also. One more connection. Now, see this one here and here itself. Here itself, then pass the data. We should pass the data here. Which data you wanted to pass? 5. And here I wanted to pass the 8. And here I wanted to pass the 3. And here I wanted to pass the 4. And here I wanted to pass the 2. I wanted to pass the 2. Guys, tell me how many nodes we have? How many nodes we have? 5 nodes. Guys, here these nodes, whatever the nodes we have, these nodes in a graph we can call vertices. Whatever the nodes we have, these nodes in a graph we can call vertices. Guys, whatever the connecting lines are there, these are the connecting lines now. Whatever the connecting lines we have, that connecting lines technically we can call edges. Whatever the connecting lines we have, then that connecting lines we can call edges. Fine. Draw the diagram. Draw the diagram, boys. Boys, nodes technically what do you call? Nodes technically what do you call? Answer, vertices. And connecting lines technically what do you call? Connecting lines. Connecting lines technically we can call edges. Do it fast. Draw the diagram, guys. So whoever watching in the YouTube also, please draw the diagram. No root node na. Here we need to specify. Aman, you need to specify. Which one is the root node you need to specify. Then I will show it how to identify the root node. Undirectional graph, not a non-directional, unidirectional graph, or a both directional graph, or a bidirectional graph. Yes, Saman, we will use it. Guys, anyone completed the diagram? Are anyone able to complete the diagram? Reply. Lakshmi. How could Lakshmi completed? Fine. Next one. See the guys. Here, how many types of graphs? We have two types of graphs. Yeah, guys, how many types of graphs we have? We have the two types of graphs. First one is the directional graph. Second one is the undirectional graph. Undirectional graph. Yeah. Can you please explain again? How many types of graphs? How many types of graphs? Two types of graphs. First one is directed graph. Directional, not directional, directed or directional, right? Directional graph. Another thing is the undirectional graph. Fine. Now I will show it. What's the directional graph? For example, this is a one node, and this is the another node, and this is the another node, and here we have one more node also, and here we have one more node also. Guys, see this one. This node connected to this node. Whatever the node we have, this node connected to this node, and one direction also. And one direction also. Guys, this node connected to this node. Direction also there, na? Direction also there. Guys, say this one. Here, and this node connected to, and this node connected to this node. And this node connected to this node here. And here. Coming to here, this node connected to this node. This node connected to this node. And here also. And here also, this node connected to this node. Whatever the node we have, that node connected here. Then this graph what do you call? Then this graph what do you call? Reply. This graph what do you call? Directional graph. Whatever the graph we have, then this graph we can call directional graph or a directed graph. Fine. Next one, guys. See the undirected graph. What are the undirected graph? This is one node. This is one more node. And this is one more node. And this is one more node. One more node. Now try to see this one. This node connected here, but no arrow symbol. This node connected here, no arrow symbol. And this node connected here, no arrow symbol. No arrow symbol here. Next one. Here itself, coming to here, this node connected here, no arrow symbol. This node also connected here, no arrow symbol. Yes or not? See this one. These things we can call bidirectional. Whatever we have, these things we can call bidirectional here. This node can talk to this node. This node also can talk to this node. This node can talk to this node, and this node also can talk to this node. So this one we can call bidirectional, or else technically we can call undirected graph. Technically, what do you call undirected graph? Guys, draw the diagram also. Guys, how many types of graphs? Reply. How many types of graphs? We have the two types of graphs. Here we have the two types of graphs. First one, anyone? First one is the directed graph. Second one, undirected graph. First one is the directed graph. Second one is the undirected graph. Guys, if possible, draw the diagram also. Only two types. Satyanarayana. Draw the diagrams. One is the directed graph, another thing is the undirected graph. Guys, in undirected graph, can we get the like a bidirectional? Node 1 can talk to node 2. Node 2 can talk to node 1. Bidirection is possible. Make it faster. Draw the diagram. Searching, na? Satyanarayana. That is called as a searching. Searching. Those things are come under the searching. Guys, are you understanding the theoretical concept? Are you people understanding the theoretical concept? Say yes or no. Are you people understanding the theoretical concept? Yes. Guys, I will tell. Guys, I will tell one example related to. I will tell one example related to the like undirected graph. I will cover one example in real time where we are using the undirected graphs. Guys, you know server connection. Guys, do you know server connection? Yes, say this one. For example, this is the server. Whatever we have, this one we can call the server. Server. Guys, see this one. And another thing. One more thing is the, guys, see this one. And one more thing is the client 1, client 2, client 2, client 3. Next one, client 4. Next one, client 5. Next one, client 6. Client 1, client 2, client 3, client 4, client 6. Guys, see this one. Client 1 connected to the server na. Coming to the client 1 connected to the server na. Yes, sir. Yes, sir. And server make you response to the client 1 na. Let's see this one. Server 1 can connect to the server 1 can connect to the server can connect to the client na. Yes, say this one. Here also. Client 2 also can connect to the server na. Yes, sir. Server also can get the reply to the client na. Yes. And client 3 also can connect to the server na. Yes, sir. Server also can get the reply to the client na. Yes, sir. Why, sir? This is what? This is which graph? This is which graph? Undirected graph or not? Undirected graph. Whatever the graph we have, then this graph we can call the undirected graph. Can you please explain again? What is a real-time example for the undirected graph? Yes, guys, what's a real-time example? Social media platform. Social media platform is one of the example for the undirected graph. And another thing is the only one edge, through that edge only communication happen. And another thing is the like a client to server architecture. Client to server architecture also one of the best example for the undirected graph. Draw the diagram. Turn right answer. Complete the diagram, guys. I'm leaving three clients. You need to take like this also. Make it faster. Yes, and one more point I will tell you. How to represent graph with the help of matrix. Then that matrix we can call adjacency matrix. Adjacency matrix. So can you repeat again? How to represent a graph with the adjacency matrix. Adjacency matrix. How we can find it? Now, how we can do that? Guys, I have one graph. Very, very important. Try to understand. Node 1. This is the node 2. Node 2. Next one, this is the node 3. And this is the node 4. Node 4. And this is the node 5. Node 5. Here, how many nodes we have? We have the 5 nodes. Fine. This is which node? A node. This is which node? B node. And this is which node? This is which node? C node. And this is which node? D node. And this is the D node here. And here we have the D node. And here, this is which node? And this is which node? A node. A node, B node, C node, D node, and E node. Now see this one. A node connected to, answer, A node connected to, answer, A node connected to B node. And A node connected to, A node connected to which node? C node. And C node connected to, and C node connected to which node? D node. And another thing, B node connected to, coming to the B node. B node connected to D node. Guys, no arrow symbols. Is it a, guys, no arrow symbols here. Is it a directed graph or undirected graph? Undirected graph, no arrow symbols here. Now, we can establish communication between A and D also. A and D also. And B can connect to, B can connect to E. And D can connect to, and D can connect to what? Coming to the D, D can connect to E here. Got it or not? Fine. How? How we can do the matrix representation? And not only that one, goes one small change. Here we have the D na. D coming to the D, D can talk to D only. Possibility is there. D can talk to D itself. Self talking here. Coming to the D, D talking to D itself. How to represent this information with the help of adjacency matrix? Yeah, self loop. How to represent what are the information we have? This information I want to represent in the form of a adjacency matrix. So how we can represent? Now see this one, guys. Here we have A, and here we have B, and here we have C, and here we have D, and here we have E. Guys, here itself. Once again, here we have A, and here we have B, and here we have C, and here we have D, and here we have E. Yes or not? Guys, any connection A to A? Guys, any connection A to A? Reply, no connection, 0. Guys, any connection A to B? Any connection A to B? Yes. Guys, any connection A to C? Say yes or no? Yes. Guys, any connection A to D? A to D? Yes or not? Yes. Guys, any connection between A to E? A to E? Reply, say yes or no? No. No in the sense? 0. Guys, any connection between B to A? Any connection between B to A? Anyone? Yes. Guys, any connection from B to B? B to B? No. See this one. Any connection between B to C? B to C. I'm talking the B to C. No. Guys, any connection between B to D? B to D. Yes or not? Yes. Guys, any connection between B to E? B to E? Yes. Guys, complete the remaining fields. Complete it. I'm requesting you, please complete the remaining fields. Do it fast. recursion. I think that one we can call the Shahil, that one we can call the recursion. Recursion possibility is there. Possibility is there. Shahil, possibility is there. You are saying how it can connect. Recursion. Node in the sense you may feel like that's one of the method. Write it. Please make it fast. Write it. You people should write it. Write it and share the diagram. How many members done? How many members are able to complete? What happened? Only 3 to 4 members are active. Only 3 to 4 members are active, guys. I need the complete. Take the pen and paper and draw the diagram. Are anyone able to finish the matrix? Are anyone able to finish the matrix? 5 members are responding, guys. Around more than 500 members are there, but four or 5 members are responding. Jigyasha, yes. Jigyasha, can you write the code for this example? I'm expecting the code from the one more example. Now try to say this one. I'm expecting the code for this example. Now you people need to write the code. So this is the node 1, and this is the node 2, and this is the node 3, and this is the node 4, and this is the node 5. Node 1, node 2, node 3, node 4, node 5. This node we can call A node. This node we can call B node. Is it mandatory to go for the A and B? I think we can take anything other than B node. Now, this node we can call C node. This node we can call D node. D node. And this node we can call E node. Whatever the node we have, then this node we can call E node here. And see this one. And here we have these connections. So this is the connection 1. This is the connection 1. Next one. And this is the connection 2. Connection 1. Next one. This is the connection 2. Next one. This is the connection 3. This is the connection 3. And this is the connection 4. And this is the connection 4. And this is the one more connection. This is the one more connection. And here we have, this is the another connection. This is another connection. Here guys, say this one. Coming to the B. B calling itself. Whatever the B we have, this is B calling itself here. B calling itself recursion here. Guys, draw the diagram quickly. Within 5 minutes or 5 to 10 minutes, we need to complete the matrix. quick. Guys, what happened? Only few members are doing. What about the remaining people? Only few members are doing this one. No. Guys, so can I discuss how to represent the graph data? Can I wait? Yes, take some more time here, just 2 minutes, guys. I will get the 2 more minutes, complete the diagram. Then I will go for how to represent the graph data. Jaiba, that's the point I'm saying B is the loop. Where is the loop, Jaiva? Where we have the loop? CDE is the loop, no? Jaiva, if the symbol like a circle, like a triangle symbol, you may say like that is the loop, no? Jaiba Sheikh, it's just like a circle, like a triangle kind of thing. By seeing that triangle, you are thinking like it's a loop, no? Fine, that is not the loop. Make it faster. Depth the first search, breadth the first search. If possible, otherwise I will share the snippet. Quick guys, what happened? Very simple diagram. You people are struggling to write the answer. I given around 5 to 10 minutes of time, but still you are taking more time. Waiting, guys. I'm waiting. Still, some people they are doing. Last 2 minutes, guys. Last 1 minute. Please make it fast. No, guys, try to say this one. Here and another thing is we need to go through the another thing. One more thing is guys, can I continue? Can I continue? Reply. Yes, sir. Guys, how to represent the data? I wanted to represent the data. Then how we can represent the data? How we can represent the data? Fine. Now see this one. Assume here one node contain 3 more nodes. Assume one node connecting to how many nodes? 3 nodes. Assume best example. I'm taking the best example. One node coming to the one node connecting to how many nodes? 3 nodes. Fine. How? See this one. For example, this is root node. A root node or A node. And this is B node. B node. And this is C node. And this is a C node. And coming to here, and this is D node. A node, B node, C node, and D node. How many nodes we have? Can you answer how many nodes we have? How many nodes? Here we have the 4 nodes. So this is the node 1, node 2, node 3, and node 4. Fine. Guys, each node divided into 4 partitions. Not to 2 partitions, 4 partitions. So this is the partition 1. This is the partition 1. And this is the partition 2. This is the partition 2. Now this is the partition 3 and partition 4. Say this one. This is the partition 1, partition 2, partition 3, and partition 4. Now say this one. And here, this is the partition 1, and this is the partition 2, partition 2. Next one, this is the partition 3 and partition 4. Next one, say this one. This is the partition 1, and this is the partition 2, and this is the partition 3 and partition 4. And here also, this is the partition 1. This is the partition 1, and this is the partition 2, and this is the partition 3 and partition 4. Here we have the number of partitions. And here we have the number of partitions here. Now, try to see this one. Guys, in each partition, assume here, can you tell the memory location also? Can you tell the memory location also? 1000. Can you tell the memory location also? 2000. Can you tell the memory location also? 3000. Can you tell the memory location also? 4000. 1000, 2000, 3000, 4000. Here, these are the memory locations we have. Guys, assume this one. Here, a second field is there now. Here, a second field is there now. Here we have the second field. Second field always contain the data. 10. Next one, 20. Next one, 30. Next one, 40. Second field, whatever the second field we have, that second field always contain the data here. Guys, here itself we have another thing. Here we have the status. This one we can call data, and this one we can call status. This one we can call status. Fine. Guys, so what is status? Visited or not? This node while performing searching operation. While performing searching operation, visited or not? Visited or not? So, guys, 0 representing what? 0 representing what? Not visited. Coming to the 0, 0 representing not visited. Fine. Coming to here, 0 representing not visited. Here coming to here also, 0 representing not visited. Coming to here, 0 representing not or 1 representing what? 1 representing what? Anyone? 1 representing what? Visited. Fine. Guys, Aman, try to say this one. What is the field 2? Aman, what is the field 2? Field 2 is the data. What is the field 3? What is the field 3? Status. Coming to the field 3 is the status. 0 means not visited. 1 means visited. 0 means not visited. 1 means visited again. Leave it. That one we need to leave it again. While doing the coding, then you can get the clarity again. Fine. Next one. Guys, see the one more point. How we can connect? How we can connect this node to here? To connect here, edge will come to the picture. Who will come to the picture? Edge. Edge will come to the picture. Now try to say this one. This is the edge. Fine. Here. This is the edge here. Can you tell the address of this edge? What is the address of this edge here? The address of this edge is the 1500. Whatever the address we have, then this address we can call 1500. So, how we can connect? Guys, link this one. You people need to link here. Jaiba, are you following? Jaiba, what's the address here? Address 2000. And link here. I wanted to link here. Whatever we have, I wanted to link here. So, how we can link here? How we can link the edge? How we can link the edge here? What's the edge address? What is the edge address? 1500. Jaiba reply. Jaiba Sheikh reply. Are you following this one? How we can represent the data? Jaiba Sheikh. How we can represent the data in the graph? This is the way to represent the data. Then this concept, what do you call? Whatever the concept we have, then this concept, what do you call? Edge concept. Whatever the concept we have, then this concept we can call the edge concept. Here, whatever the concept we have, then this concept we can call the edge concept here. Fine. Next one, guys. How to link this one also? I want to link this one. How we can link? If you want to link, create another edge. We should be in a position, we need to create another edge. See this one. This edge also divided into two partitions. Whatever the edge we have, that edge also divided into two partitions. Whatever the edge we have, then that edge divided into two partitions. Fine. Now see this one. What is the address of this edge? What is the address of this edge? 2500. 2500. Guys, see this one. Here, what we need to do? Guys, store this address here. Whatever the address we have, this address we need to store. How? How we can store the address here? Can you tell how we can store the address here? What is the address of this edge? What is the address of this edge? 2500. Now, and another thing. Store this edge here. I wanted to store this address here. Whatever the address we have, then I need to store this address here. Address here. So what's the address of it? Can you tell the address of it? Here we have the address. The address is the 3000 is the address here. Got it or not? We have the address here. What is that address? The address is the 3000 is the address. Guys, are you okay with this one? Guys, are you okay with this one? Yes or not? Fine. Guys, how to connect node 3? I want to connect to node 3. Shahil, how to connect to node 3? To connect to node 3, we need to create one more edge now. We need to create one more edge. So what's the address of that edge? What's the address of that edge? Can I tell the address of this edge here? This is the edge now. This is the edge here. Here this is the edge. Here we need, what's the address of it? Can I tell the address of it? The address is the 3500 here. Here we have the address here. The address is the 3500. Guys, where we need to link? Where we need the link here? We need the link. Whatever the address we have, that address link we need to store here. Yes, sir. Here we have what we have here. Can I tell what we need to place here? We need to place the 3500. No, guys, see this one. And another thing. Another thing is this node address we should store here. Whatever the node address we have, that node address we should store here. How we can store this address? Answer. How we can store that address? Whatever the address we have, then address we need to store here. Got it or not? Yes, guys. This is the diagrammatic representation. Whatever we have, this is the diagrammatic representation. Diagrammatic representation what? Diagrammatic representation to represent the graph data. To represent what? To represent the graph data. This is the diagrammatic representation to represent the graph data. Go ahead, draw the diagram. And I think you may ask, sir, what about the remaining fields? So you may ask like that, but we can place like this here. But there is a last one here. You can place like this here. Guys, you know linked list concept. Guys, here we need to place whose address? 2000. Guys, here we need to place whose address? Whose address? 3000. Here we can place whose address? Whose address? Tell me here. Here we need to place whose address here? We need to place the 4000 address here. Guys, here we need to place whose address? 5000 address, but it's not there. But we can place the other addresses also. And we need to link the nodes like that, guys. We need to link the nodes like that. So whatever the vertices are there, these vertices also we can link like that. Take the diagram. I'm expecting you people need to take the diagram. Guys, in this diagram, can you please answer? We need to write the code for the vertices now. We should write the code for the vertices now. Yes, yes. No, there's a temporary connection. Money, there's a temporary connection. Don't think that there's a permanent connection. There's a temporary connection. Because to know how to proceed to the next level, don't think like that node addresses are not required. Only edges are okay. You are asking like, oh, sir, why you are placing the node address also not required? That is not required. To understand yourself, then I'm placing. Like in the future, I want to know how many connections are there. Yeah, guys, see this one. Here one more pointer. Guys, here we need to build. Here we need to build vertices and edges na. Guys, we need to build vertices and edges na. Reply. Yes, we need to build vertices and edges. Guys, if you take the vertices, what's the second field? What is the second field? Answer. What's the second field? Data. What is the third field? What is the third field? Status. First field is the data. Second field is the status. Guys, and here field 1 contain what? Edge address na. Edge address or not? Field 1 contain edge address. Guys, field 4 contain what? Another vertices. It contain what? One more vertices. Reply again. Guys, what is the field 1? What is the field 1? Anyone, at least one person. What is the field 1? Edge address. What is the field 2? Data. What is the field 3? What is the field 3? Status. What is the field 4? What is the field 4? Can I tell the field 4? Next vertices address. Field 4 is the next vertices address here. Am I right or not? How? How we can build it? Can I tell how we can build it here? Guys, in the core Java, we need to create one class or not? We need to create one class or not? Respond. We need to create one class. What is that class? What vertex class? We need to create one class. That class we can call the vertex class. Yes, next one. Say this one. Here, can you tell field 2 and field 3? Int data comma status. This is the field 2 and field 3. Next one. And here we have the edge also. Na? Here we have the edge. How we can create it here? Edge. Here we have the edge. Edge edj. Edge edj. Next one. Here we have, and here we have vertex. Vertex next. Vertex next. Here we need to close this one. Here we need to close this one. Got it or not? Got it or not? Yes. Reply Harshita. Harshita, please give the response. Yes. Guys, coming to the edge. Edge contain whose address? Edge contain. Edge contain whose address? This is the edge. It contain whose address? Vertex address and another edge address. One. How to create it? Class edge. Class edge. Contain what? Contain what? Whose address? Vertex address. Vertex. Vertex, we need to place the link. And here we have another thing here, edge. Take it slowly and clearly. Definitely for the whoever appearing for the exams, definitely it will helpful to you. Whoever appearing for the exams, guys, it will be very helpful to you. Vertex, yes, fine, no issue. Where is the spelling mistake? Fine, leave it now, leave it. Aman, leave it because I can't edit it again. I can't edit it because now I'm using the Ubuntu operating system. We can't edit it. You are saying the instead of I place the ina, leave it. Draw the diagram. Is anyone able to finish? Aman, what happened? Aman, what you are asking? Can we complete this today means? Aman, what you are asking? Done? Anyone able to finish? Graph. You were asking the code. I have the sum code. I have the sum code. Then I will share it. No need to worry because a live implementation not possible. Okay. Then already I will explain the snippet. Guys, anyone able to complete this one? Yes. Guys, say this one. Here, I will share some snippet to you based on that discussion. Based on that discussion, guys, will you people analyze this code? Just analyze this code. Whatever the code we have, you people need to analyze this code. After analyzing this code, then I will explain that internal snippet to you. Fine. Now, just a theoretical concept, like whatever the theory I done here, same concept we place it into the one pictorial or in coding format. Guys, download this code and run this code. Are you able to do or not? So Smita, please upload this code also to the drive.
Yes, sir.
Guys, I did learn something in the today's session like a graph concept. Reply. Send the text file one. I sent the text file only, not other file. We sent the text file. Guys, check that one. Is it opening or not? No, it's not opening. No. Wait here. Where is this code? Desktop. Now, where is the desktop, guys? I'm unable to see the desktop. Wait here. Can I do the drag and drop like this? One second. Graph code. Yes. Check now. Check now, guys. Check it whether we are able to see the coding or not. Yes, yes, we got it. Fine. Guys, are anyone able to run that code? Are anyone able to run that code? Guys, vertex 0, contain 1 to 4. Yes, guys, whatever the theory I told here, just map that theory to that code, then you can understand it. Anyhow, in the tomorrow session, first a few minutes, I will explain that snippet. After that, tomorrow directly I need to go to the lead code questions and hacker rank questions. Once if I complete, still we have the one more thing, that is the like which one? We have that time complexity, space complexity. Tomorrow, that hacker rank questions and the lead code awareness I will provide. Day after tomorrow, I need to go for that time complexity, space complexity. Guys, did you learn these 2 weeks or something? Are you happy? Did you learn something? At least awareness. Awareness. Yes, yes. Fine. Yeah. Susmita, you can hand out the session.
Yeah, sure, sir. Students, I hope you are all marking the attendance. I'm sharing the attendance link once again on the chat. If you missed out the attendance, kindly mark the attendance. We'll wait for 2 minutes, then we will wind up the session. Certificate you will not get now only. After the completing of this course means the like Friday is the last day. So after 1 week, within a 1 week, you will receive the certificate. Kindly wait for it. You will not receive it by today or tomorrow only. 2 more days are left. Friday is the last date. So some are asking about the new classes. So the new program will be starting on 9th. That means from Monday there is one program. So if you want, you can just register. Okay, guys, I hope you all marked your attendance. We'll wind up for the day. So we'll meet again by tomorrow. Thank you all. Good night.